Hey, what's up, guys? So, people have been asking me about how I figured out this seventh, being able to calculate the fifth, sixth, seventh number of the Collatz conjecture without going through all of the steps in the Collatz conjecture, such as if it's even, we divide by 2. If it's odd, we add 3, and we multiply 3 times the number plus 1, and then that goes on until it falls into this 1 for loop. What I found was you could jump straight to the seventh number by doing some various calculations based off of where an odd number falls into this 8-block sequence. And each one of those sequences has 8 positions in it. And then it has a block. Each block has a block number as it goes down through the odd numbers. So if you have odd numbers like 1, 3, 5, 7, 9, each one of those has a position in this block of 8, and then every odd number past that has this position in these blocks. And what happens is in some of these blocks, in these 8 positions, you'll have various, like that 8th position will have, for instance, depending on the block number, so you have like a 1 block, 2 block, 3 block, 4 block. What will happen is in that second block, the formula will alternate in the 9th or in the 8th position. So it could be, and there could be 4 alternating up to when we get to the 7th, there's 4 alternating positions. For instance, in the 8th position, there are 4 different alternating formulas for that 8th position. And when you're in the 5th position, there's no alternating. So it's like one simple formula that solves for each position in a block of 8. So, and there's a formula for finding that. It's pretty like, basically you're saying, okay, if we have 8 positions in a block, and this number is 50 trillion, what block would that find? You would divide by 8, and then that would tell you, okay, if I divide the number by 8 blocks, it's this block number. And then that will tell you, then based off of that, you can calculate out this number, and it will give you the 7th or 8th position, or 7th, in this case, the 7th position, or the 6th position, or the 5th position of the Collatz conjecture. And so what this helps us figure out is if we can go and we can jump straight to the 7th number of any number, basically it's like super fast, right? Because you just jump in 7th number, 7th number, 7th number, 7th number, 7th number, 7th number, instead of having to go like this, rotating through all the numbers of all the calculations that have to happen based off of like if it's odd or if it's even with the 3n plus 1. And in this case, it kind of shows too that there's like patterns that are happening throughout the Collatz conjecture. Okay, so where does this start at? This starts at this concept that there's a pattern going on with 3n plus 1 and 5n plus 1 and all of these, like 7n plus 1. There's this consistent pattern where it's pushing out every time you run an odd number through like 3n plus 1, right? So if I run an odd number through 3n plus 1, it's always going to give me an even number. Well, that even number will always have a certain number of numbers that it will divide before it becomes an odd number. And that pattern for odd numbers follows a certain sequence. I could show you that in a block pattern here, where this is not 3n plus 1. This is actually like 7 or 8. I was playing around with it. So some script that I wrote. And yeah, see, I have 7n here. We can change that back to 3. And you'll see this block jump down to where these are, this This technically means that when you take 11 and you run it through 3n, well, in this case 7n, but let me run this really quick. What's happening is there's a pattern that's happening throughout all the odd numbers where a certain odd number jumps up. So once you kind of understand this layout, which I won't go into super in depth right now, but basically what happens is this odd number, when it goes to 3n plus 1, has so many, it will give you an even number that has so many sequences that it will divide before it's an odd number again. So when we understand that, then we can kind of understand this concept of how these filter up to this kind of bit and byte scenario, right? So what's going on here is, like, you could see, this is where I kind of initially just figured this out. If you look at this pattern, you have 16 goes to 34. It's a difference of 18. Difference of 18 down here in pink on this line here, you can see 52 minus 18 is 34. 34 minus 18 is 16. So there's this pattern that keeps going on with these. This is the sixth number in the Collatz conjecture. And there's this pattern that keeps going on, and it goes on for the other numbers in this as well. So when let's say we drop to this blue section here, and we've got a difference of 28 from this, let's call it blue, to blue, right? 18. This is also 18, right? So we saw that there, 18, 18. And then if I come down here, if I add 18 to that, I'll get this number here as well. And so there's these, in these blocks of 8, which you see here, 16, 106. Okay, so we'll count these 1, 2, 3, 4, 5, 6, 7 numbers in between. So this would be like what I would call a block of 8, right? You could see that. I would call this a block of 8. And then the block of 8 starts over. And all of these tend to match up. Occasionally what will happen is that it will skip. So this one, and for say like this number here, like, it wouldn't create a pattern. So that's where we have in the formula that you can see in the code that I posted, that's where we'll see these like rotating patterns. If it's odd, if it's odd and this number is odd, then it becomes like because what happened, and I wrote this basic script so you could see this. Couldn't find it that day, so I just rewrote it. But what this tells us here is that when we take, let's say we're trying to find the 5th number of the Collatz, and we run the Collatz, and then we take all the 5th numbers and we break them out into, starting with for odd numbers only, we take them and we put them on a grid, on an 8 wide grid. So we've got, this is the 5th number of the first odd number, 1. This might actually be 1, 3, 5, 7, 9, 11, 13, and 15, right? So those are the going down the odd number sequence. So then what happens is, based off of that sequence, we can start to say, okay, does every 9th or 8th number, or 6th, 7th number, 5th number down that sequence, when you break them out into this grid pattern, does that have a pattern to it? And so if we look here, we've got, this is going to be what we call a base number. And then I call this an interval. Like it could be a difference. I call it an interval. So I take the base number here, and this would be considered like the grid. I shift this to a +1 in the equation. At the time, it seemed like a good idea. So what I'm doing is I'm saying, okay, what's the difference between this fifth number and this fifth number and this fifth number and this fifth number. Well, we can see it's a difference of 6. But what happens when you're trying to like find so many numbers down for like this sequence in the equation is that you find out pretty quick that it's pretty hard if you don't have some type of a reference to like multiply by. So that's why we use the block numbers in the equation. And it's essentially an index, right? But I just called it a block because these are blocks of 8 numbers. And so what we do then is we take the number, right? The base number of 5. Okay, and we multiply the base number by, per se, like the index number, right? Which is actually going to be, in this case, it's going to be plus, no, sorry, we do a, yes, we're going to add that. We're going to multiply by the difference, the interval. How many is the difference here? And we see a pattern of 6. So we're going to start here and we're going to say, okay, I want to find out whatever this number was. Okay. Whatever this number was, what we did was we ran an equation and it told us that number, right? This number, which we could print here if we wanted to. This, and I'll show you that in this. This number here, okay, this number had a block number of 7, right? So then what we would do is we'd go, okay, had a block number of 7. We know, let's go up to here. This is a little easier math. It had a block number of 5. We multiply 5 by the interval of 6. And then we have 30. Well, then we add the base back to that number, the base, plus 6 times 5 is 30, which gives us a fifth number here of 35. And that seems to work for like I've ran this for like millions of steps just to check. And in this case, for the fifth number, it works. 7, 6, and 7 get a little more complicated because the formula will start to do all these like sub-block alternations, odd, even intervals. So I'll show you the fifth one, and you can look, and we'll look at the code for the 7th, and I'll show you where that's processing and how it's processing. So in this one, don't mind the code here. This is just some early version of this where I was trying to move through it as quick to see how far I could go up. Could go up further, but what I noticed is that there becomes like a block issue where you have to have like a higher starting number because some of these numbers start to become, they start to use a like they go back to that pattern of 1, like 1, 2, 1, 2, 4. So this is finding for the 6th number. Now the 6th number has that rotating pattern in it, and I can show you that in the code here because you can see some of these, like on the first position of a block, I've had to check to see if the block is odd or check to see if the block is even. And then if the block is odd, then I do this like this 1n, 1 minus n, and that's because I used block position of starting with the block calculation I told you about, where we divide by 8 and find the block that number would be in. I did that on not on that index level starting with 0. So that's why we have the -1 going on here. So the block position -1, sometimes we've had to divide the block value by 2 to get this answer. And so there's some of these weird like nuances that are happening within the equation. So, and you see that really start to happen in the 7th, which is a little bit more difficult because you're looking at, okay, when I go 8th, 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 in this script pattern that I showed you back here, when I'm going, it's like these become much more complicated as you're trying to find for a higher position number. And so if we look back at this equation here, what you could see, and this down here in the code, this is just for testing. It's why I have the Collatz here, but up above, okay, this formula won't work, like I said, for any of these, because this position is going to alternate. So if you took this formula and you tried it for any number and it didn't work, try the second alternating one that I showed you there for the formula. So when I take a number, like this has a specific starting number as well, which I think is 5. When I take, because if I do 1, let's see. Yeah, see how they're. So basically, if I take a number like 31, okay, and 31, if I plug that, if I find the block of that, we'd find out that it's block 2, right? And when I find out that it's block 2 and I plug 2 into here, 2 minus this, and then I do this formula here, it comes out to 107. You can check it, but it does. And then if I plug that in down here and I check it, let's see here. Oh, sorry, let's just do this here. 31. Oh, 31. Okay, and we're looking at, look, yeah, like 107. So, and then the next one is going to be 33, which is right here, 33. And if I check that one, it's going to be 19 here. And this next one would be then 35, right? So 35. Let's go back up here and check that there too. 35. Yeah. So 35 right here is 20. So you can see that like the formulas work, and they work to like an extended. I mean, I've done just some crazy, numbers here, and then you can copy this. Oh, just copy this number down here, run the Collatz on it, do a search, and there it is. So this concept is that it's like all of the Collatz is related in this like kind of like this 8-bit is what I call like an 8-bit structure, and that goes back down into my spreadsheet. But you'll see here, if you take these basic formulas that I showed you back here, right? And you look at these increment values, and you look at these, and you take this, this to find the position, this formula that I'm showing you here to find the position. Let's see. This is one. Amazing to find the position. I know that there's a position and block number, block position. Yeah. Let's see. So yeah, let me do something here real quick. Second. Oops. Okay, 1 second. I want to show you the formula. I'm just not like right off the bat. Like I did this a while ago, so I'm just looking. It's pretty easy to find the formula for this, where it's like take an odd number and find out in a block of 8 what position it's in. numbers per block 8. So it's this constant. So it's, let's see, we'll find this. Yeah, it's this. Let result. Yeah, this is it. This is the position. Divide the index after here's the formula. So basically, this is just gonna like find where that block is at, right? So that one, it's not a hard formula, but that's the concept. So then you find out this block, then you find out this position, and you can figure out that this nth number, right? This one's the 6th number, is going to show up here, and it works. Oh, I've tried it for crazy numbers, and it just seems to always just work. So I haven't found any. Say so. I mean, they're both fast. Like when you think about how fast this is really like calculating this whole situation, right? That's going on. It's like still really fast. But I know that some people are trying to calculate out like these massive numbers. In the class, it doesn't make sense because I don't want to go into this whole idea of like what I think the proof is and what a proof really even is. But this concept, I believe, kind of separates out this idea that, hey, look, this pattern goes on. It goes on for the 5th. It goes on for the 6th. It goes on for the 7th. And there's something else that's going on in there as well that's causing these to rotate with inside of these positional blocks. I haven't explained that. I kind of got to this and a few other discoveries that I can share with you guys. But this is yeah. So this is how I'm calculating these, and you can see in the 7th, this one that I posted on the code pen, that this is not as detailed as that other block position one. This just kind of tells you the answer, which is, I don't know why I simplified it to this. Maybe I shouldn't have, but it just kind of, that's because it's an odd number or an even number. And I have a whole theory about that. So, but this one kind of plugged the number in so you could see it. You could see the block, you could see where it plugs in the calculation, does something kind of a little bit different than the other one did. So yeah, that's my presentation. People were asking me how this works. It works on this block system. And inside of this, if you look at just a basic block one, you'll see it's a lot easier to understand. This one here is just a single equation. The 2nd position in any block of 8 numbers is a single equation. The 3rd one is still a single equation. That actually, this first one goes back to a single equation, because before, when we looked at that one in the 6th number, it rotated, but then it goes back to a single one. And then in this 4th one, it goes to this another equation. And then it gets into this one, which I understood the cycle, and this one I'm not even going to try to explain because it just goes into some like crazy, like there's some stuff that's happening there where there's like 5 different patterns and one's like skipping every other. And so it goes into some of these like pattern skips, but it still solves it just straight to the 7th number by kind of going through this case loop, which doesn't say like, you're starting with an odd number. So, and the reason for that, and the reason why the Collatz, I think, has to be solved by figuring out the odd numbers, is because the even numbers, they just always divide into an odd number. It just keeps dividing, right? It's just it's an even number. So it's just that, I think when we kind of throw that out, it changes a lot. And there's some theory and stuff I have around that, but that for now is this explanation. So I hope that helps. So if you have any questions, feel free to reach out. Thanks, guys, gals. Here. Thanks. Bye.